Hi everyone, welcome back to our channel. Today we will be looking at the PAW6 inlet test case from the 6th AIAA Aerodynamics Workshop. We have previously meshed a 2D case and have also shown you how to convert the 2D grid to a 3D grid. More specifically, today we are looking at meshing geometry model D, in which the individual bleed holes and plenum chambers are fully modeled. Additionally, there are 3 vortex generators in the center body and 4 in the cowl interior. This video is part 1 of a multiple part series. Today, we will only be meshing the region consisting of the discrete bleed holes with the plenum chamber which is integrated in the cowl and center body. Meshing the vortex generators and the rest of the geometry will be addressed in future videos. We will use GridPro's hole topology feature to ease the topology creation process of the bleed holes. The tool has the ability to automatically create the blocking and the internal surfaces for the specified holes in the geometry. Before using the tool, however, there is one important thing to be noted. The number of bleed holes in each row is not the same. The two rows on the cowl have 17 holes each, whereas the two rows closer to the inlet on the center body have 15 holes each, while the two rows farther away from the inlet have 14 holes each. Hole topology creation. We shall now start by creating the topology using the hole topology feature. We shall start by creating the topology for the upper two rows of bleed holes. To do this, first we group the top surface and bottom surface in separate surface groups. Now we group all the bleed holes in both rows in another surface group and specify all these surface groups in the tool window. Add the respective surface groups in the drop downs for top surface, bottom surface, and holes. The holes have a regular four-sided type of topology. Check the link holes option, which automatically links the topology in the two rows of holes. Select the rectangular type of pattern. The preview shows us how the topology will be linked. Since this is the correct linking, we need not edit it. Make sure you provide an empty corner group to add the peripheral faces into. This corner group will be very useful for us later on. Clicking on Apply creates the following topology. The internal surfaces closing the holes are also created automatically by the tool. We similarly create a topology on the lower two sets of rows with equal corners. Linking the lower set of holes. To link these two set of holes on the bottom center body, we first need to match the number of exterior blocks between the two. It will be unequal as the number of holes is unequal, 14 holes and 15 holes respectively. To match this, we need to add 4 inserts on the wireframe having 14 holes, 2 on the top and 2 on the bottom, using the peripheral faces corner group. We add inserts on either side of the 7th or 8th hole in a row having 14 holes. We do this using the corner group having only the exterior faces. We now group the two sets of exterior faces to be linked between the two hole groups and link them. Linking the lower and upper row of holes. To link the lower and upper set of corners, we first have to create an equal number of block faces to be linked. Since there are only two rows of holes on the cowl, we group the left and rightmost exterior faces and wrap them to create a topology to match the topology on the center body. There is still an unequal number of corners between the two wireframes, which prevents us from linking them. This is attributed to the fact that there are an unequal number of holes on the upper and lower holes. The center body wireframe has enough corners to link to 15 holes on the cowl. However, since there are 17 holes on the cowl, we need to add 8 inserts, 4 on the top and 4 on the bottom, on the center body to match the number of corners and faces between the cowl and center body. We can now link the exterior faces on the lower side of the cowl topology and upper side of the center body topology. Wrapping to the boundaries. Now we use the exterior faces of the new topology to wrap it and assign them to the plenum boundaries. Now we do the assignments on the two end plane boundaries. Make sure to wrap the exterior faces assigned to the end plane boundaries as well. Upon checking the validity, we see that we have a valid topology. Density modification. The densities can be changed either by adding inserts or by changing the edge densities. The preview tool comes in handy while modifying densities. Running the grid smoother for a couple of hundred sweeps, we are able to generate a good grid with low skewness. Thank you for watching. If you like this video, leave us a like and subscribe to the channel for new videos. If you have any questions or comments, feel free to leave it below. If you want us to post tutorials on any specific geometries, you could write to us on support@gridpro.com. Follow us on our social media pages. Links are posted in the description.